My mic was muted. Make sure my mic's on, actually. All right. Always good for people joining in to double check that you can hear me as well, even though it looks like you should be able to. And welcome, everyone. As you're joining in, also say hello in the chat. It's always really fun to see where people are watching from. What are you currently learning? Why you were interested in this event today? And I'm going to wait a minute before we really get going because I'm even a minute early starting this, but I always like to get the stream live a minute early while people are joining in. So say hello in the chat. Also, if you do want to join this stream, I'll probably mention this a couple times. So I don't have just a invite link open for anyone to click on. It's not a Zoom meetings, but if you do want to join the stream, you can message me on LinkedIn. And I shared the link if you want to connect there, but also if you want to actually join in. Also totally fine if you want to stay just in the chat. I know a lot of people like interacting in the chat, and that's awesome. I like that too. But I do like to invite other people to come up and join and talk with audio or video if you want. And I think we're going to have another person join as well. Oh, yeah, I see John. Let me just add him in. Welcome. How's it going, John?
Hey.
Cool. And people are still rolling in. So I'll do a kind of intro to the event here in a second as well if you weren't at the other ones. People are saying hello. Someone says hello from San Diego. Someone said, hey, welcome. Again, put in the chat. It's fun just seeing people say hello because you know there's like live people. But if you want to put where you're watching from, that's always fun. And then also today we're kind of talking about reinforcement learning, but more specifically about a specific tool, OpenEnv, which we'll go into here shortly. So maybe a good question too, has anyone used OpenEnv before? It's a very new tool, so my guess is no. I had poked around with it actually when it first came out, but that's it. Just did like a Hello World demo. And then if you've done reinforcement learning before, I think both of those things would be kind of fun to answer in the chat. If you've done reinforcement learning, if you've looked at OpenEnv already, maybe if you've used other environments, you could throw that in the chat as well. Someone else is watching from San Diego. And someone said they are currently building. Oh, let me actually turn on the chat to show up inside. So this makes it maybe more fun for people watching as well across streams. So it said, hey, they're currently building a bunch of AI tools. Their current favorite is a Chrome extension to analyze current website and save notes to vector database for semantic search later. That sounds awesome. Also, let us know what topics you want to discuss next. I guess I'll kind of maybe go into the event here a little bit since we're a couple minutes in. So welcome to the AI Build and Learn. It's kind of a weekly, hopefully it's going to be weekly. It's been weekly for the third week. This is the third one. It's a weekly AI engineering stream where we pick a new topic or tool and then kind of learn about that tool together. Hopefully, I'm trying to learn about it through the week. I know a lot of people also probably just join the stream, and that's totally fine. But the idea is for me to kind of have a forcing function to, during the week, go and check out this tool, spend like an hour or even just minimum like 30 minutes learning about that tool. And then I try to build a demo every week with it too. I know not everyone might have the time to do that. So I would just recommend like, hey, see what tool is listed or the topic that's listed. And if you're not going to build something, you could totally dive in and learn probably quite a bit about it in 30 minutes, like reading a blog or the docs. But I definitely encourage people to build with it. And then we also have a Slack channel. Everything should be linked in the description, by the way, too. There's a Slack channel, so I create a thread for that new topic every week. And this week's topic was reinforcement learning with OpenEnv, which is what we're going to hop into. The previous weeks, we started with MCP with, I used fast MCP. There's also the official MCP client, which some people used. And then we did agentic search with Tvili. So all the code is here in this repo, which I should also share. So if you want to come back and hopefully get like a friendly starter example, they're going to be in here. If you also want to commit code, like build an official example or build an example during the week and commit it, you can do that here. Like John has done that actually, I think every week, which is an awesome. Hopefully it was fun for you, John, having this as like a forcing function to dive into that topic and actually build an example. They've been really cool so far. So if other people want to do that, I would recommend you could follow the GitHub. I think joining the Slack is probably good. I already posted the link in there. And then you probably already found this event on Meetup or Luma. Those are the best places to kind of stay engaged. And I saw you unmuted, John. So I don't know if you want to say anything.
Oh, I just wanted to support your comment. Yeah, it's been fun to take these topics and spend some time diving in. And yeah, I wish I could iterate at your speed and produce a demo in an hour. But
I spend a little bit more than an hour right now. I'll be honest. I'm trying minimum. That's the goal. Not every week, because I don't have time. Everyone doesn't have time, right? Or that much time through the week maybe to do this. If you do, that's great. But yeah, the expectation is, especially for newer tools that haven't been around for a while, like, I'm not going to always be the expert in it. I'm trying to dive in. We can talk through stuff, have a discussion around it, and then hopefully get over that kind of hump of like getting started with that tool. And then you can use this tool, what you've learned or what you've built, as something you can come back to later when it actually maybe is useful to you. And we have a list of topics too. So if you have recommendations, what you want to do next, post that in comments here or in the Slack. We have a whole bunch already listed. I haven't made the next events yet, but I'll be making them soon. And the next one is going to be next Friday. Is going to be auto research, which you might have heard about from Andrej Karpathy. It's a really cool concept of having not just a model fine tuning itself with like changing hyperparameters, but actually changing code. So we'll be diving into that next week. I'm excited to set that up like on my own personal machine and play around with it. With that though, we can go into this week's topic. So we're looking at OpenEnv. Again, in the chat, let me know if you've already seen this before. This is the official GitHub repo for it. This is out of the Meta team, and it's officially in the PyTorch Foundation. Meta also created PyTorch. And this is it's an agentic execution environment. It's a end-to-end framework for creating, deploying, and using isolated execution environments for agentic reinforcement learning built using Gymnasium-style simple APIs. So I don't know if anyone has done reinforcement learning before. If you have, like if you were studying this a few years ago, you probably used Gymnasium, or this originally was from OpenAI. Now there's another open source fork from it because they stopped committing to it. But you got like these kind of simple environments. When they say Gymnasium API, what they mean is they have kind of these pre-built functions like for creating an environment and then seeing the observation of that environment. We'll go into this a little bit more, but that's like a big part of reinforcement learning, which there's different types of reinforcement learning. Now you see it talked a lot about for LLMs, and actually a lot of the examples, they use an LLM to interact with their environments here. But kind of the core of reinforcement learning is you have an agent, which had a different meaning from the LLM agents back in that use now. But you had what was called an agent, I think still called an agent, and it usually would observe the current state of their environment. And so this gives you an API to create that environment and observe the state of it. And then it chooses an action, and this API also gives you ways to create those actions. So based on it chooses action based on a decision-making strategy that it comes up with, or a policy that you give it. And usually you get a reward saying that was a good or bad step that you did. And then you want to kind of learn from that. And then it's going to update the policy over and over again. So they give you an API to create the environment. And the kind of cool thing with this is that this environment can be used, like you create it, you can actually push it up to a Hugging Face hub if you want. But basically it's a server. And you can actually then go ping it. I think when it's on Hugging Face Hub, I actually haven't tried it on the official hub yet, but it's like a Hugging Face space. So once it's deployed, should actually be able to interact with it. Although if you're doing a lot of training, that seems like a lot to actually go ping something and wait for a response back and forth. So I think it's also designed where you can host these locally, which is what I did. So you kind of create a API hosted locally. You can then share that environment across different agents. So I actually tried that with my kind of example that I built, was doing more traditional reinforcement learning. And then I was trying to use an LM to also solve something within that environment. We can look at that in a little bit. So they have an API for creating that. And then just like I was saying, then they give you an API for creating, for observing the state of the environment. And I'll show some visuals here in a second of like the thing I built if it helps you visualize if you haven't done this before. It has reset and then step. So these are all basically actions. It's going to see the state of the environment that you give it, and then it's going to create perform some sort of action, which is a step. And then you might want to reset that environment for it to run over and over again and learning. And they even mentioned here, this is early development. So there's actually not a ton of examples yet. If you go to their hub even, or if you go to they have an examples folder here, but if you actually go to this blog post, this is created with Hugging Face as well. If you go to this blog post, they mentioned they have an environment hub. So this is where you're going to see like official environments that you can, I think, interact with hosted here, but also you can download them. And they don't have that many yet, but they're doing a big hackathon on, do I have this open? On April 26th. So I think we're going to see a lot more after this. Unfortunately, I think the registration for the hackathon is already closed. It says deadline was April 3rd. Maybe they extended it. You could go look. But this is super new, like I mentioned. So there's not a ton of environments, but there are ones that you can go choose from here. So you have like Atari, which is kind of like some of the simple Gymnasium ones that you might have seen before. OpenSpiel with some other games. Let me share this link in the chat as well. So you can kind of browse these, but it gives you the API to create your own environment too. So you can do whatever you want with it. It just makes it easy for you to provide those states to your reinforcement learning agent in this case. And a lot of the examples too, currently from what I saw, are using like LLMs to interact with those environments, which is interesting. So you have a kind of a physical state, like an environment, and then you can train a LLM to navigate it. I was trying the small LM that's really small from Hugging Face, and it was not having a great job even with GRPO on it. But I think if you used a larger one like the Quinn, even 500 million parameter with some reasoning, would probably do a good job of like solving things like the maze. Any comments on this so far? People think it's interesting. I'm gonna catch up on the chat here too. Someone said they just got their home lab set up with a DGX Spark. Ah, awesome. How's the DGX Spark going? I actually also have a DGX Spark. That's what I was working on with this. Actually, I was training locally, and then I was training this on a remote cluster. But having the Spark is super helpful for trying out the larger models. I would love to know what you're learning. Oh, I see. It's Niels. I know Niels. I'm sure I will learn more about what you're learning. But having the DGX Spark as your kind of home lab thing has been really fun for me so far, just because it's hard to get any consumer GPUs that have more than 32 gigs of RAM. So we've only looked at kind of the API here. There's also from this link, you can go run this in Colab and stuff like that. Any comments or questions on this so far? Otherwise, I can kind of go into my quick kind of demo that I can show you that I made. And again, all the code, even John's example, I'll share this one more time too, is in this GitHub repo. So my demo, also this links out to all the links that I basically was just sharing as well. So I wanted to create an environment that I could also visualize. Neil said, how different is the OpenEnv API from the Gymnasium one? So I didn't do a direct comparison, but I think that I did have Claude try to do a little bit of a comparison, and it's in this specific topic actually for today. So I did not double check this, but it does kind of sound right from when I used Gymnasium again a long time ago, and I haven't used the newer fork recently, so I don't know if they've added a lot of stuff in there. But the idea is that with OpenEnv, you get each environment runs in its own server, and it could be its own container. And I think John's example actually has this running in a Docker container. When I was looking at it, I see him nodding his head. So I'll see that in action from John today too. And then the idea is that you can give it remote access. Again, I'm not sure if you're doing a lot of training, maybe this isn't for training, maybe it's for running and stuff later. But the idea is that it kind of has remote access built in by default that you can host this in a Hugging Face space, or I've hosted in a Flyte app where it can be deployed remotely, and then I can have any agent, no matter where it is, with an internet connection, go interact with that environment. Again, for training purposes, I don't know how good that is, but for interacting and doing something, I think that's pretty interesting. Oh, and we'll see this in action too, but the way that you define the actions and everything like that uses the pedantic models. So you actually define state of your environment, and then the actions for your agent are all defined as like pedantic models, which is kind of nice. So I think that's the biggest thing, is like they do this separation of environment that's just really easy. And then they even say it's a Gymnasium style API. So if you're kind of familiar with these types of things, but it's a little bit different way of organizing your environment versus your agent, I guess. And then they actually, like I'd mentioned a couple times, like they deploy it to Hugging Face app, but I think it's actually built in to the thing. You can deploy this anywhere you want, but they have something like if you just say push or whatever, it'll go to your Hugging Face space and deploy there. So one of the examples I built real quick, and I can go in the code here, but I'll show in this report. This is a Flyte cluster on Union here. And you can see my training report is built in, where I did these eval baselines, and then I trained. I tried both, doing more traditional deep Q learning with which had way better results for my type of environment, and then also getting started with a LM, like I mentioned, a very small LM that I think would do better with a larger one. So actually, I don't think I've looked at this run yet. So let's see what it did. We could see that solve rate, it actually learned to solve this 4 times. Get some other metrics here. Oh, let me go in and go to the full report. This will actually have playbacks. And we could see that it's pretty traditional in like reinforcement learning, that you'll start with a couple of things to maybe get a baseline, and then you want to see that your model is doing better. So the random baseline, it did actually solve. Wait, did it solve it? I think it does solve probably here, but in 137 steps. While following, which is a classic thing, how to get out of a maze, you just always turn right or left or something like that, and then you'll often end up at the exit. It did it in 22 steps, and I should update this color here, but we can see that my DQN actually did end up solving it faster than Wildflower with 16 steps. And you can see this is the solve rate for it, and then some other metrics like the loss and exploration. And then here is the playthrough. So let's see this random one. It does start moving. It goes in random areas. Eventually, it does seem like it gets down, even though it's stepping all over the place. And then we can see wall follower. Again, this isn't the reinforcement learning yet. These are getting baselines of like, can our reinforcement learning algorithm get better? And then we can see that first untrained, it failed. It's just moving around. At 10 steps, it failed as well. But it did. You can see it's kind of learning how to move around this maze. And then at 30, it actually does end up solving it. You can see it happened to go down that correct path, and it's basically learning to get higher rewards here and take those steps. So now it's solved it in 16 steps, which is faster than our wall following. And you can see it's still training here. And it gets better and better at solving it almost every time after a few steps. So when asked how long do the tests take, I'm not sure which test specifically you're talking about. In this case, training this one with the DQN on that environment that I made, the kind of the simple environment using OpenEnv, was only like 5 minutes on a T4, I believe, kind of a lower end commercial GPU. And I did it on the DGX Spark, and it was also pretty fast. And then, so all the code is in there. I'm not going to walk through every part of it. But if you do want to check it out, you can. And then the main thing that's kind of the OpenEnv thing is we have our environment created inside this maze environment. We have a little app that we can serve. And then this is the actual environment part where you define all the states and basically build that maze graph that we were seeing. And then the other OpenEnv part really is this models.py, which contains those pedantic models that we were talking about. So basically you're saying maze action, you could choose an action. In this case, it's a direction with a string, but you would define this, whatever those actions are for your environment. And then we have maze observation. This will return back basically the state of where the agent is within the maze. And then you have the maze state. And the Q in the Q in deep Q learning stands for Q value, I believe, originally, which came from, if you did like classical reinforcement learning back in the day, you could do reinforcement learning without a deep neural network, basically. And the Q value comes from that, like you could have a grid, and inside of that grid, it would take a step or like pretend to take a step. And then basically you'd get estimations of that being the right step based on rewards. And then that was like where the Q value came from. And it works really good on very small grids, but when we get bigger grids, and I think that equation, correct me if I'm wrong, it might be, it's like bell curve or not bell curve, Bellman equation or something like that for the reinforcement learning. And then, but with the deep Q learning, you have a neural network that can do basically larger estimations on those steps versus the just Q learning without the neural network piece can't estimate on larger grids. So it might have done well on a small grid, but it probably would not learn as fast or fail way more than the deep Q learning here. And then again, this maze environment can be shared. So I started working on the maze environment with an LLM, which you can take a look at in here. This uses the small VLM and then GRPO to try to solve it. And then I have this deep QN. I should actually probably just import these from that models.py, but I copied them here again so it knows what moves it could take. Gets the maze environment. This is a setup to run in a Flyte cluster. So I set up a Flyte task here. And then when I ran it, like when you saw in that UI, I just declare exactly the amount of GPU, CPU memory I want directly in here, what libraries I want. It actually runs in a container too. So I don't have to define my container as a Docker file, just do it directly in Python here. And then we give it the actions that it can do within the maze. And then, yeah, I won't walk through every part of this because it looks like a lot of code. A lot of this is also just kind of like some HTML stuff to build the reports. But basically it plays the episode and then it generates the replay. And it does the evaluate baselines that we just did. And then it actually trains on the thing. Happy to go back through the code more, but I don't want to take up the entire time on my demo. So any questions so far or comments? Again, you can go check out all the code too in the repo, which I'll share one more time. And if there's no comments specifically on that one, we can go into John's. John, are you ready to demo?
Yeah, sure. Thanks. I took a slightly different approach to this, more of from a business perspective. Like, okay, if I'm a owner of a team, why would I invest our resources into OpenEnv? And so I was really curious about the differences, and I put together. Is my screen showing up? My screen.
Oh, there we go.
Oh, there it goes. All right. So I put together, this page, which has multiple demo modes. There's the side-by-side comparison of traditional classical reinforcement learning approach versus what OpenEnv has to offer. I leveraged just some learning from last week's session, so I wanted the actions to be Tavili based, right? And in the classical model, it basically didn't have a lot of flexibility, right? It just used Tavili search. Whereas in the OpenEnv model, natively throughout that code, it was smart enough to use Tavili search and Tavili extract. And I'm showing you something that's already run. So the purpose here is that you select an example question, in which case, the example question here is, how does retrieval augmented generation compared to fine tuning? I'll just select another one here. I'll select the second one, and then I'll do max steps at 6, and then I'm just going to run it as a local process and hit run comparison. It should only take about 20-30 seconds, but here These are running in Docker containers. Looks like it'll come back up. So it's going to search, and here you can see in the traditional model, it's just doing keyword stuffing, and then it's gonna grade it. You can see that it's grading it relatively high on the traditional model, and that's mainly because the model isn't as knowledgeable as the OpenEnv design. So in the OpenEnv side, you can see it's going through. It's used. The first three were search, then it went into extract, but it's not. It's broader and smarter and more capable than just the traditional model. And then you can see the final score for the LLM judge of the traditional model being 0.30 and the LLM judge score being 0.70. So, for me, the value here is by using OpenEnv, I get better results, right? So there's a brief little summary here in terms of, how OpenEnv works. Sage, you talked about the actions and we set the step in the state. The other portion of this demo is an agent race. That one takes a little bit longer, but you can hit start race, and effectively that's intended to show the durability of OpenEnv, meaning it's going to run multiple agent calls, and they're not going to break. And then the last one was the fan out. This was more to highlight running on Flyte. And I'm very new to Flyte, so I'm still learning this here, but this is just it's a result summary. I just max steps 5. It takes about 90 seconds to run, but this is what you would see after you run it, right? So I fed it 3 questions. So here's the 3 questions. The type of agent that each question uses. So each question uses the OpenEnv agent and the traditional agent, and then the steps that it takes, and then the keyword score and the LLM as a judge score for both of them. And in all results, you can see that the OpenEnv is higher LLM judge score. So then at the bottom, the big question I have is, hey, what's just stopping me from, putting in the manual wrench time to perfect my classical model to do more what OpenEnv does? And it's just time and money, right? Could you do it? Yeah, but it's a bit easier right now with OpenEnv to include more actions, and also you get the durability right out of the box versus having to program that in. So.
Cool. So you're using OpenEnv as like an environment for the agent to interact with while it does something like the research?
The environment is containerized, but it's the OpenEnv agent.
Right. But I'll have to go look at your code, but it contains like the actions to do.
Yeah.
Like, it's almost like a in a way MCP, but with OpenEnv a little bit.
Yeah, a little bit.
Cool. That's interesting. Yeah, that's a cool different use case. That's awesome. And that's what I was saying too, how like when I went in thinking about it, I was like the training environments and stuff like that, because that's usually what I've done like for reinforcement learning as well. But like I was saying, they're building it as a hub where you're going to have these hosted environments. And so I wonder if the idea ultimately is to do something like, I don't know if MCP comparison is right for it, but yeah, kind of like here's an environment where just any agent can go connect to on this hosted thing and do certain steps in.
Yeah. I mean, ideally, I wanted, you could see here where I've got the run mode, the Flyte task versus the local process. And I was playing around because I'm still, looking at Flyte, and I wanted to tell a story around, the benefits that Flyte brings from an infrastructure and stability, on top of OpenEnv, but didn't quite get there. But yeah, this forum's satisfied that the purpose anyway is to get hands-on, to get curious, and so thanks.
Yeah, this is awesome. Thank you as always for building really cool demos and showing them off here. If you do want to try a remote Flyte thing, I could probably get you onto a like a try cluster if you want to mess around with it.
Yeah, I went to the site. It forces you to use a work email.
Yeah, I can get you onto like a demo cluster. I think if you want to build around and play with it, it'd be really cool.
Oh, that'd be fun. That'd be fun. Thanks.
Cool. What do people think? Questions, comments from the audience? Seems like a cool. I like that it was a different use case. That's awesome. Or what do people think about OpenEnv so far from what you've seen? Are you going to go check it out, use it in any projects?
Yeah, I tend to look at this again from a stakeholder / business perspective, manager perspective, and it's the scary part for me right now is the early stages. So if we go and take a software path to make OpenEnv a standard for many of these things, right? Is that going to be long lived? Or are we going to be unwrapping things 6-12 months down the road? And that's the I can definitely see the benefits right now in terms of, I think it's definitely easier to bring in more actions and expand your reinforcement learning space, with this framework. But the challenge is how long lived is it? Is it going to grow? So,
yeah, and I guess you never know. It's in the PyTorch Foundation pretty early on from Meta. Meta built it. I wonder if they have plans for it, or they're already using it internally for something, and then they decided to open source it. That's likely what they're doing.
Yeah.
And Niels asks, it looks pretty flexible. Build stuff is it pretty general, i.e., not just for LMRL? So like I actually had mentioned I was trying the LMRL, and then I ended up not using the LMRL for my environment. So if you remember, like the Gymnasium environments with like Atari games and stuff like that, you don't have to use LMs at all. You don't have to do reinforcement learning with it either. It's just made for reinforcement learning. So it gives you the step state type of API, but definitely not just for LMs. That was one of the questions I had actually when I first looked at it too, because all the demos that they had built were around like fine tuning LMs to play games or do something. And then I ended up solving the maze environment that I made with a deep Q learning type of thing. Which someone also asked about the model texture for. You can share your screen again. I'm just going to show model architecture is really simple actually for the deep Q neural network. In this case, pretty simple maze. So it's actually just a 3-layer perceptron or multi-layer perceptron. And just takes the input numbers, which is like the grid and then positions. So that's like the state size. And then it tries to predict basically just from the action size, what is going to get the highest Q value. So if you had a bigger environment, you'd want to build probably a bigger neural network, but that's why this also trains just in like 5 minutes and you get really good results. I think it started solving it actually very early on. So in like a minute or a couple epochs or steps, as they call them in reinforcement learning. I put your screen back up if you wanted to show anything else. Also in the
this
repo.
Was just
go ahead.
This was the agent race. It's not very exciting other than the fact that, it simulates inside a single Docker container, each with its own fully isolated session. So there's no shared state, no inference between the agents. So
what is the race doing again?
It's running typically search against a research question. So, but it's using the open, like I said, it's kind of it's just an agent, but it's using OpenEnv. So it's not, definitely different from your demo.
Yeah, this is awesome. I love that it's different. That's the coolest thing about having people build stuff is like very different use cases, which is awesome. And I also love that John built on the last, basically the last work or the last stream or two. The last one we had like the Gradio app in Tavili, which is Tavili is a tool for like adding search to your agents. So it's also just cool seeing like a progression of that type of all the tools that we're learning. Basically, I think that's really.
I ran out of credits. I had to go and pay the $30 for more credits.
I guess that's what happens when you have 3 agents searching at the same time, right? Yeah, the developer tier of Tavili is really good. It gives you like 1,000 credits a month for free or something like that. But I could see it being easy to blow through them if you have agents racing.
I'm gonna get my $30 worth now. So I think I'm up to 2,500 now. So I'm gonna keep testing.
Someone said great demo, which I think they mostly saw your demo too, because they said they came in late. They said great demo. What are the reinforcement learning architectures currently supported? And if I have a custom reinforcement learning model architecture, how can I use it with this setup? Yeah, so if you missed it, I'll take back, or I'll share my screen again, John. That's cool. If you missed it, so again, everything is kind of linked within this GitHub repo if you want to check it out. But OpenEnv is basically just a high-level API structure or a high-level structure to define environments that you can create the where was the step? Like you basically create you get APIs to create environments, and this is like if you'd used the Gymnasium before, you get like step actions, state of your environment. They're easy to return. And then you also get them in a format that is an isolated container. So like they basically spin up on their own container, whereas their own application, and you can ping them from different agents, multiple agents, an agent from anywhere with an internet connection if you have it deployed somewhere. So to your question of what architectures are supported, really anything that you want to bring to it, it's not limited to any architecture that I can think of, as long as you can read a state and perform a step action. That's all you really need to do. And then the other question is that you came in a bit late. Is there some tools for reward function tuning that is available on the platform? I don't know if there's I didn't see anything specific about like reward function tuning for it's like specifically built into OpenEnv. So I don't know. I know there are other tools, like open source tools for that. And if anyone has any tools they've used that they like, put it in the chat, share it in the chat. What kind of reinforcement learning architecture are you building with? That would also be interesting to hear about. Yeah, take a look at their official repo too, the OpenEnv repo. This kind of links to everything. And like I was saying, they're pretty small sample size right now of examples, but I think that's going to grow this year because I think they're really starting to push more usage with that upcoming hackathon in April. And this just came out. You can see the commits are from at most 6 months ago, I think. And I don't know if that's when it was officially released. I think it was maybe technically came out in October, but I think they started talking more about it in like December or something. So it's very, very new tool. They even mention, I think I showed this before, I think it's in their repo, somewhere in the repo where it's like, this is early. Yeah, early development. They're warning you. So API might change. I'm sure they're going to add a lot of stuff to this too, especially like we don't know, but it's like if this is something that Meta is using internally and then they decide to open source it, we'll probably get a lot of cool new stuff that will come out of this. There's also already some cool integrations with like art, for example, which is from OpenPipe. OpenPipe is was a local Seattle company, which is where I'm streaming from. And they got acquired, though, by CoreWeave recently, which is cool. They might be fun to do a stream on, actually, using OpenPipe. So they have some really cool reinforcement learning stuff that they've built. Any other questions, comments on OpenEnv or any of the other quick kind of demos we did? Kind of like watching the watching the maze being solved while people are coming up with questions. It's actually kind of fun to see the like it solved. Let's see what happens. It solved it this one time, and then the next run it didn't solve it. So I'm curious like which direction it went instead. Oh, it went down. Kind of got stuck in this loop there, I guess. And there's some reward policy that I changed in here where you are basically making it like explore more than just following policy reward, because if you do have it get kind of stuck in a loop, like it will never find new paths and stuff like that. So that's probably why it solved, and then it tried new directions, because I didn't want it to just go down one path. Like what if it wasn't the shortest path, it went this way, and then I want it to find the other one. So you kind of add some randomness in there too, saying, hey, don't just follow your complete reward hacking, which happens all the time in reinforcement learning. Actually add in some stuff. Neil said they would love to see something that takes the data / metadata produced in agent harness sessions, Claude, open code, and then turning that into an OpenEnv environment. Oh, that'd be interesting. And they have not that, but some of the environments in here, because a lot of them are around LMs and stuff right now. Some interesting ones too, like they have a browser gym environment. They have a coding one, I believe, too, code environment server. So I wonder if there would be something around like taking metadata from, if you're doing this in a code environment, and then building that into an OpenEnv. That's a really fun idea. Maybe we'll have to work on that, Niels. That could be another project. Yeah, because it's so flexible, it seems like you could really kind of create any environment that you want with it. Maybe not the more complex 3D simulation environments. I guess that's, this library isn't for that. Like I was working on another reinforcement learning project recently, which I hadn't done reinforcement learning in a long time. And then now I feel like I've been doing a lot more of it. But I was using like MujoCo environment. And then I want to look at the Isaac lab simulation environments. I don't know if anyone's used that, but that looks awesome. Has anyone been doing more like reinforcement learning or anything recently? Oh, I was going to look up Isaac. And then another question for everyone, as always, is what topic do you want next? Next week, we have the research, auto research, which should be really fun. And then after that, I don't have the other ones booked, but I know there's quite a bit of a list that we were talking about. And I think high on the list, I haven't ordered them yet, but it sounded like a lot of people last time wanted to do like a vector database type one. So even someone in here was talking about how they've been using a vector database for a cool application. So we might do, and then someone want to do graph databases and graph neural networks. So I think a good progression, like we were coming with last time, that a lot of people seemed interested in, was doing something around like using a vector store for, we could do this for RAG, but also agent context, I think. And then maybe we do a graph database or a graph type of RAG / context thing. So often what I've heard too is it's best to use both. So you might use a vector database to do the initial search, but then a graph database to see the actual connected nodes. I think that would be interesting. And then evals has come up quite a bit too. Any other topics though people want? Oh, and someone asked, what was the 3D environment? Yeah, let me pull that up actually. Make sure I get it right. So there's a whole bunch of them. I was using MujoCo. Is a very popular one that's also open source now from Google now. Owns it. Originally someone else did. And then the one I wanted to check out that I haven't used yet is the NVIDIA Isaac, which looks really cool too. The other one though, MujoCo, is pretty popular. see. I'll just share the GitHub link to that. Someone said RAG examples with Amazon Bedrock. Amazon Bedrock's come up quite a bit too. I haven't used them yet, but yeah, it could be interesting to dive in there. I might have the, I mean, we could do RAG example and then you could build one of the Amazon Bedrock actually. I don't know if you're interested in building something. If you do that, then you're welcome to come up and show it as a demo too. I might keep it a little more open for not tied to a specific paid tool, just so anyone can kind of jump in and get started with it. But I don't know, does Bedrock have like free credits to get started with? But noted, Bedrock has come up several times. Oh, and that was the Mujiko one. This is the Isaac Labs. There's a whole bunch of other ones too, but Mujiko is one of the more popular. Cool. Any other questions or comments? Otherwise, we can always wrap up the stream a little early, which often we have. 45 minutes is a great amount of time for me. Hopefully, this is really fun. This weekly stream, again, is kind of meant to be a somewhat casual session, just mostly even talking about a tool. So if you want to come in and join or have other tool recommendations, let me know. It's always fun. It's been a fun forcing function for me to at least go in and start building with it a little bit. Again, I'm not always an expert in it either if it's a new tool to me. So this is more of a fun way to kind of get introduced to it and then have a discussion around it. Niels asks, what's the cheapest robot hardware out there? I know Hugging Face has the clothes folding one. I guess, do you mean like a humanoid robot? I know Hugging Face has, was it the Reachy Large or whatever is the one with arms, and then Reachy Mini is their newer, smaller personal assistant one that is like a way cuter Alexa. And actually, they have a skill space for that on Hugging Face now too, because people are building cool stuff, and I've been tempted to get one. But you could build your own pretty cheap robot with like a Raspberry Pi, depending on what you're looking to do. If you want arms and stuff like that, it's not included. Hugging Face also has the arm, just the arm. So maybe that's what Niels is talking about too. There's, I forget what it's called, but they have an arm that integrates with Le Robot, which is their like robotics training and data library. One of my friends has it. I actually helped him build it. And it seems really cool. And that seems decently affordable too, but I think at least the version he had, I think there's different versions with different tiers of motors, is still like $500 or something. And so it said Pi Arduino. Yep. And again, depending what you're doing, Arduino is really cheap. A Raspberry Pi Pico is like $4. Maybe it went up $1 with memory inflation. I'm not sure, but very cheap. But you're going to be limited with like what models you can run on it if you're trying to do machine learning. But a Raspberry Pi, you can run super lightweight models on. Like I've done that with object detection models. And then I actually got a AI hat for the Raspberry Pi that I forget how many like flops it brings over or tops, but it could run I think it's the 500 million parameter Qwen 2.5 on it decently fast, which is pretty cool. So I was actually thinking about using that as my own personal assistant type of thing to build. Oh, and the same person just said Pi and AI Hat Plus. That's exactly what I got. Yeah. So the newer AI Hat Plus, it can actually run small language models on. And it's not that much. Like it's still going to be a couple $100 or a few $100, I think, if you don't have a Pi already, and then getting the hat on top of it. But the Pis have input outputs as well, or just serial communication. So it can then communicate to a Pico or an Arduino and then do movements based on that. Because I think actually the hat might take up the input output pins. So you probably have to do another form of communication out than the traditional IO pins out of a Pi. But you can totally do that, and then you would just do that to like an Arduino or a Pi Pico. And the person talking about Raspberry Pi hats or mentioning them, have you built anything fun with them? Well, this is really fun as always. Let me go ahead and get a link again. So if you want to stay connected, join the Slack channel, or you can connect with me on LinkedIn. I usually post about all the events we're doing. Slack is pretty fun. It's actually been way more active recently. A lot of people are joining in, introducing themselves. There's an intro channel. Join the introductions channel and talk about your robots there. They said they're building a pet robot. I have been thinking about building some sort of fun robot thing. And I used to be real into robotics when I was like a teenager and built a lot of what was at the time called the beam style robotics, which I forget what the acronym stands for. I think it's like biology, electronics, aesthetics, and mechanics. And the whole philosophy around those robots, it was before microprocessors were super cheap too, or accessible. So like there wasn't like Arduinos everywhere and stuff like there is now. So the idea was you'd build behaviors with like analog circuits, like using transistors and stuff like that. And that was really fun. So I remember having a couple pet robots or insect like robots walking around or crawling around in my room all the time. They said based on PyDog. I haven't looked at PyDog. Let me bring that up real quick. PyDog. Do you have a link to that? PyDog. Oh, wait, based on PyDog. Is this the Sun founder PyDog, maybe? This guy? And Kenny said, thank you. Thank you for coming out and talking in the chat. It's always super fun. This has been a fun, I don't know, hopefully it keeps being a weekly tradition. But you got to let me know what tools we want to talk about. Nice. This looks fun and something that you could build at home and kind of. Servos that are just attached to some plates. Maybe you could 3D print something. It's got a Raspberry Pi on its back, it looks like. Some sort of hat. Ultrasonic sensor. Camera. It's just a Pi camera in there too. This looks fun. This looks cool. I'd love to see, like, if you're actually working on that, I'd love to see what that looks like, because I might want to do that as well. Oh, powered by LLMs. So I bet this runs. Does this have an AI hat in there? Or is it connected virtually to an LLM? Yep, they said they 3D printed a lot of it. That makes sense. I have an Ender 3 that I haven't gotten a ton of use out of. So this would be a really fun project. Awesome. Follow up in Slack. Yeah, I'd love to see it. You can throw it in any channel or DM me on there. It's more fun if you throw it into other channels for people to see. But feel free to just DM me as well if you want. But this looks fun. All right, I will wrap up the stream. Thank you again, everyone. It was really fun. Hopefully, I will talk to you all next time, and hopefully you play around with OpenEnv. It seems like a really fun tool. I think I'm going to keep this in my tool belt and kind of see where it goes, and probably build some fun examples with it in the future. I like Neil's idea too about using it to, track metadata and then build like a coding environment based on that metadata. That actually seems like potentially very powerful. All right, I'm going to end this though, and hopefully I'll talk to you all on Slack, on LinkedIn, at the next stream. Keep an eye out. Thank you.